Hi guys, so today we will draw the graph of rational function fx equals to 1 over x squared, and you guys see that 0 cannot be the value of x, so the domain is negative infinity comma 0 union 0 comma positive infinity. So to draw the graph, let's make a table for the x value and y value. So this is your table, and you guys know that if I plug in 0, this function is undefined. And if I plug in x equal to 10, and you see that y equal to 1 over 10 square, which is 0.01, right? And if I plug in x equal to 1000, let's say 100, then my y value will be 1 over 100 square, which is 0.0001. So if I plug in the negative values, if I plug in negative 10, I'll get the same 0.01, and if I plug in the negative 100, I'll see the y value is 0.0001, right? So from the table, you observe that as the absolute value of x increases without bound, as x, the absolute value of x, increases without bound, the graph of fx moves closer and closer to what? X-axis. The graph of fx equal to 1 over x squared moves closer and closer to x-axis, so which is y equal to 0. So therefore, this y is equal to 0. This is a horizontal asymptote. Okay, so let's see what will happen as the values of x approach to 0. Okay, so let's say I have a value of x 1 over 10, and then my y value is 1 over 10 square, which is 100. And if my value of x is, let's say, 1 over 100, which is close to 0, right? This is 0.01. So my y value, if I plug in 1 over 100 here, I will get 10,000. Similarly, if I pick the negative value, let's say negative 1 over 100, my y value will be 10,000. And if I plug in negative 1 over 10, so it will be 100. You see that as the value of x approaches to 0 from both directions, right? As the values of x get closer and closer to 0, the value of fx increases without bound, right? So let me write down here as x gets closer and closer to 0, fx increases without bound. Right? That means fx approaches to infinity and x approaches to 0. So, and you also notice that as x approaches to 0, from either side, the functional values are all positive. These values are all positive because we have a square here, right? So, and you see, well, let me draw the graph of this function. So the graph of this function, this is my x-axis, and this is my y-axis. Okay, and 0, -1, -2, okay. And the graphs, it looks like this. The graph looks like this. You see that as x approaches to 0, fx, the y value, increases without bound, and as the values of x is very, very large positive and large negative number, so that means as x increases without bound, your fx gets closer and closer to 0, right? So therefore, from the graph, you can see that this x-axis is horizontal asymptote, right? And this y-axis is vertical asymptote. Okay, and so if you look here, the function fx equals to 1 over x squared increases from -infinity to 0. You see that the graph increases, right? So fx equal to 1 over x squared increases from negative on the open interval -infinity, 0, and decreases on 0 to +infinity. See that? And this is discontinuous at x equal to 0, because the function is undefined at x equal to 0. And I already wrote down here the y-axis is the vertical asymptote and x-axis is the horizontal asymptote, and this function is an even function, and this is symmetric with respect to y-axis. Symmetric with respect to y-axis. And if you want to find the range of this function, so range is the set of y values, and y value is always positive, right? The graph is above the x-axis, so the range is going to be 0, +infinity. Okay, guys, so let me erase that. So the next is, today we'll talk about asymptotes. So if you have two polynomial functions, let's say px and qx, and you have a rational function rx, the ratio of px to qx, where qx is not equal to 0, okay, and this is written in the lowest term, okay. Let me write down here. Okay. So, and we have a real numbers a and b. Let's say we have a real numbers a and b. If absolute value of fx approaches to infinity as x approaches to a, then x equal to a is a vertical asymptote. Okay. If fx approaches to b as absolute value of x approaches to infinity, then y equal to b is a horizontal asymptotes. Okay, now let me give you a simple example. You guys know the reciprocal function 1 over x, and you see that as x approaches to 0, fx approaches to infinity, right? So that means x equal to 0 is, right, x is equal to 0 is vertical asymptote. Okay, and you also see that here fx approaches to 0 as absolute value of x approaches to infinity, right? So that means y equal to 0 is horizontal asymptote. Okay? So this is the definition for the vertical and the horizontal asymptote. But if you want to determine the asymptote, it's very easy. So let me talk about determining asymptotes. So let's start with the example. Okay, suppose we have a rational function fx equals to x squared minus 4x minus 5 over 2x squared minus x minus 10. So if you want to find the vertical asymptotes, so to find vertical asymptotes, we simply set denominator equal to 0. So 2x square minus x minus 10 equal to 0, and then you solve for x. And you know how to solve it, right? So you multiply 2 and 10, 20, and what are the factors of 20 that makes negative 1? So this is negative 5x plus 4x minus 10 equal to 0. So now from the first two terms you can factor out x. So this is 2x minus 5 plus from the last two terms you can factor out 2, which is 2x minus 5 equal to 0. So again you can factor out 2x minus 5 because you see the common factor. So 2x minus 5 times x plus 2 equals to 0. So now you use the zero factor property. So that will give you 2x minus 5 equal to 0, or x plus 2 equals to 0. So if you solve for x, this is x equal to 5/2. And if you solve for x, and x equal to negative 2, right? So now this x equal to 5/2 and x equal to negative 2 are vertical asymptotes, okay? So what are the vertical asymptotes? So x equals to 5/2 and x equal to negative 2 are vertical asymptotes, okay? So if you want to find the horizontal asymptotes, to find horizontal asymptotes, so we look at the numerator polynomial and the denominator polynomial. So if we have a rational function of the form like this, let's say Rx equals to an x to the power n blah 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 a0 over bn x to the power n plus blah 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 plus b0, where an and bn is not equal to 0. So in this case, the horizontal asymptote will be an over bn, which is your an is 1 here, right? And the bn is 2, so this is 1/2, right? So it will give you y equal to 1/2 is horizontal asymptote, okay? So, but here, so in this case, like, okay, if the degree of numerator polynomial and the degree of denominator polynomial are same, in that case, y equals to leading coefficient of the numerator over leading coefficient of the denominator, is going to be the horizontal asymptote, okay? So but if you look here, this rational function, it does not have oblique asymptote. Fx does not have oblique asymptote. Okay, so let me write down something about oblique asymptote. If the degree of numerator polynomial if the degree of numerator polynomial is exactly one more than the degree of denominator polynomial, then there will be an oblique asymptote. Then there will be an oblique asymptote. Okay? So in this case, the degree of the numerator is 2, the degree of the denominator is also 2, so that's why it does not have an oblique asymptote. Okay? So let me give you this next example. If we consider polynomial function f(x) equals to, let's say, x squared minus 5 over x plus 3. So this is a rational function, right? So what is the vertical asymptote? You know, to find VA, which is the vertical asymptote, we simply said denominator x plus 3 equal to 0, so that gives you x equal to negative 3 is vertical asymptote, right? But now look here, what is the degree of the numerator here? 2. What is the degree of the denominator? 1. So now the degree of the numerator polynomial is exactly 1 more than the degree of the denominator, right? So in this case, this rational function has oblique asymptote. So how to find oblique asymptote? So to find oblique asymptote, we divide x squared minus 5, this numerator polynomial, by denominator. We find the quotient, and y equal to quotient will be the oblique asymptote. So let's divide x squared minus 5 by x plus 3. So this x plus 3, we can write down x minus negative 3. So if you compare this with x minus k, then you see you will get a k equal to negative 3, right? So we can use synthetic because this is in the form of x minus k. So you have a negative 3 here. I'm going to use synthetic. Okay. So this is negative 3. And then we write down the coefficient of x squared, which is 1. So we don't have an x term here, right? The x term is missing, right? So we put 0. And we have the constant negative 5. So we bring down the first coefficient, which is 1. Negative 3 times positive 1, negative 3. And we combine this. 0 minus 3 is negative 3. And negative 3 times negative 3, positive 9. And negative 5 plus 9 is 4. So this is a remainder. Okay. And what will be the quotient? So the quotient, let's say qx, denoted by qx. So this is going to be, you see, x minus 3, right? And so y equal to qx, okay? And y equal to, what is your qx? X minus 3 is an oblique oblique asymptote. Okay? Thank you guys.